Good evening, everyone, and welcome to the second and final night of the Southeast Louisiana Youth Council's virtual shouting program. My name is Subdin, and I'm joined by my fellow executive board members. Like last night, we'll be asking the questions that you, the viewers, type into the chat box. So please be respectful and considerate of our speaker and fellow viewers. Tonight's program is shorter, but is still jam-packed with lots of information. Please welcome Dr. Daniel Kogler. Throughout the event, you will learn about Dr. Kogler's experience in computer science, which includes his research during college. Now let's stop with the introductions and get straight into the program. Take it off, Dr. Kogler.
Hey everyone, so as Philip said, I am Dr. Daniel Kogler, and I've been working in computer science for, at least since 2011, not including some minor things I did back in high school. So I've been doing this for a while, so I've got quite a range of experience, and I'm going to go through everything that I feel I'm comfortable talking about that I did publicly and see if maybe some of that might catch your interest. So I put together a quick little slideshow just talking about the different general topics of having life with computer science. First and foremost, I feel like I should mention that even if you don't want to make a career out of computer science, there are some general purpose usages of having the ability to program. That includes improving your problem solving skills, because if you have a problem, then writing a program to solve that problem is a really quick way to not only make it easier for you in the future, but you understand the problem in more detail, and that'll help you figure out other problems later. You can also make personalized apps, and you'll understand how programs work in general. That last part is something I feel is just something sorely lacking, but slowly becoming more and more less lacking in the general public, just because basically our entire lives revolve around computers these days, more so than a lot of people even realize. Like your microwave, it actually is running programs on there, and most people just don't even think about that. Oh yeah, and of course, once you get good at just doing little things, you can always show off what you did, which is something that I'm about to do right now. So hang on. I think I'm just going to do a full screen share because it's going to be popping up different windows for a moment. So this here is that picture you just saw. It's one little app I made a long time ago, at least 10 years ago now. I call it the fourth dimension, and it's basically just because I was curious what it looked like for different objects in 4 dimensions. Like this here, these are the different axes in a 4-dimensional grid. So you got your X, your Y, your Z, and W for the 4th dimension. And I can just rotate them around to show how things turn in 4 dimensions, and I can change the shapes. So like here is a 4-dimensional cube. We can rotate that around too. And I'll say I put this together in about maybe a day and a half. Because it turns out the math really isn't that hard. Once you learn the computer science, like how to program an app, it's just a matter of looking up what the math is and then applying it. So you don't really have to be a math whiz, because someone else has already done most of the math for you. You just have to then translate it into software language. And that same program that I just created that in, I also spent some time working in game development just as a hobby. And I got kind of far in it. I stopped after a while, but I have this up and running as well. I just need to switch which project we have open. And unfortunately, this was made so long ago that updates to the engine have made certain parts of it unplayable. And I'm not going to spend too long just showing off a game I made 10 years ago. But I still think it's kind of fun to see what you can do, because if you want to go into game development, you can do it either as a career or as a hobby. All right, while that's loading, I'm going to go ahead and just talk about it. So yeah, the good thing about game development is that you can make whatever you want. I mean, you can do that with any program, but with game development, there's always an engine there for you, or there usually is, that you can just build on. And any good engine can make any kind of game. It might not excel at any kind of game, but it should be able to support any kind of game. And making games, I believe, is a great way to flex both your creative and your problem-solving muscles. I'm going to go ahead and new share just the game itself. And we're just going to go through part of one level. Okay, that's maybe a little bit loud. So this was probably my favorite of the levels that I actually got around to making, simply because it shows off basically every mechanic I put in there all at once, aside from a few gimmicks for different levels. And as you can see, I'm green right now. This level, the starting gimmick is that you're poisoned the whole time. You need to eat the ladybugs to stay off the poison and not die. You also can't touch any of the purple or those green coins. And you can puff up to bounce off of enemies higher than you could normally jump. And you see I'm collecting all these green things. They're going to be required at the end. An earlier stage showed you that they are necessary for getting past these purple blocks eventually. I did another ladybug so I can last a little longer because my timer's almost done. Okay, and that's all the different green things. And then this thing is where you just need to croak and call the little fairy helpers to get rid of the purple stuff. Okay, and then after that, it's a bit easier in the level. But yeah, it's basically your standard platformer, and made 12 levels total before I stopped playing. No, 13 levels total before I stopped working on it. And this, by the way, was made in the, well, you can see it up there, Game Maker Studio engine, which is the same one that I believe Undertale was made in. And Deltarune, and I just missed that jump up, so I can't get up to the top anymore, but whatever. Oh, and I died. All right, I guess I'll go ahead and stop that. That should be enough of a demonstration. Okay, and then there is one more round of hobbyist things that I want to talk about. That's with Pi development. I was going to show this off, but I changed my location at the last minute and forgot to take my Raspberry Pi with me. I currently have it only set up to work via local network, so therefore I can't connect to it from a different area. But yeah, basically, whenever you're programming a Raspberry Pi, which is what you can see here over on the right, this device right here, you can connect different bits of hardware to it. As you see, I've got lots of wires coming out. They're connecting to a breadboard, which has some LEDs on there, which you can turn on and off. You've got a temperature and humidity sensor, so you can get updates on what your room is like at that location, at least. And it's got an infrared sensor as well, so you can detect if someone walks into the room. And it does a pretty good job of that, except we have cats, so it's going to go off all the time anyway. But yeah, and it works really well. You can program the Raspberry Pi to interface with the hardware however you want. Like one thing that we've done both in the class that I teach and I've done on my own is have it basically set off an LED should the temperature go too high or too low so that you can see what it's doing. And you can program it to do the same with humidity. Like if you want to make sure you don't have too much humidity near the Raspberry Pi, have an LED go off in case it's detecting that it's high, and you'll know that maybe you should put in a dehumidifier or something. One thing about working with Raspberry Pis is that this is, of the different hobbyist things I mentioned, most likely the most difficult one to get into, simply because it's got such a wide and simultaneously deep skill area that you need to delve into. Wide in the sense that there are a lot of different libraries out there. There's lots of different hardware you can connect, and they all have different ways of interfacing. So your options are huge. Deep in the sense that some of the skills that you need to learn to really do well with a Raspberry Pi, they're a bit advanced. But that's kind of a good thing if you want to look at it that way, because then you're jumping in the deep end. You'll learn advanced skills that other people don't pretty quickly, like how to run your own server that you can connect to via the web. It's really useful. Just web development and server development, that is a big part of app development, at least for websites these days. And after that, I'm going to get into the various careers that I've held over the years. And I'm not going in order. I'm going to basically go from, I want to end on the one that I did the longest, basically. I don't really have any particular order. App development career. So this is one thing I do. I'm not just a teacher. I also develop the app that our program runs on. There are different courses that we offer. And as someone who's been working on it in a couple of years, I feel like I'm qualified to tell you what it's like to work for a company developing their apps. So by the way, that's the specific kind of app development I'm talking about, is when you're working for a company developing their apps, not whenever you're a freelance app developer. So one fun thing is that you get to use popular libraries. So you're building up your resume as soon as you do this. That way it's easy to move on to other jobs in case this one doesn't work out for you. You can contribute to programs that others are using, so you get a sense of accomplishment. You know that you're making something that is useful to other people. And that's especially true for me because I can immediately see the impact of what I'm doing. In fact, I use this app, so I know that what I'm doing is helping because it's become more bearable to use ever since I started working on it. And some of my other instructors have been working on it to make minor improvements as well. And I know that they use the things I've changed as well. This is, I'm not going to say the hardest path to go down, but it's up there. That said, once you develop your practical skills through some app development experience, it's going to be relatively easy to find a job because this is the kind of software development that almost every company needs. Now, the downsides of being an app developer for a company is that you have to do what the client wants or what your company wants. So you're restricted in that way. You can't just do whatever you want. Now, you can always sneak in a couple things as long as it's not going to interfere with what they want, but you got to be careful with how far you go. Another downside is that you're most likely to deal with quote unquote bad code, and other people who follow behind you, they're going to think you made the bad code. Just a heads up. But that's because when you're working in app development, especially for a company, you're going to be working with code that other people wrote. And that most of it was probably written a long time ago. So it's got bad practices according to modern standards. It's got some stuff that's really outdated. And it's going to be a bunch of code. In fact, I'm about to show you some of that right now. You end up having more difficult hours. Generally, a lot of companies expect a lot of you really fast. And you're going to often end up dealing with some niche software, like they have their own personal preferences, or maybe some other developer 5 years ago made a special library that only they use, and it's not well documented. So it is one of the harder in terms of technical skills areas to go into. And just briefly, well, here, before I switch to the other share, this is the website that I've been working on. It was around long before I ever joined the company. But I have been contributing to it a little bit. Especially, I can't really show off most of what I've done because most of what I've done is either in asynchronous classes, which we don't currently have available to the public, and therefore I can't demonstrate, or it's has to do with attendance, and since today is a Saturday, there are no attendance things to be checking. But basically, if I were to go, I can't show you that anyway because I'd be showing student stuff. Got to keep the student information confidential. But yeah, basically, I put in a lot of quality of life improvements in here. if I were to click on a session, now it will be going to the current date instead of you having to scroll over halfway across the year to get the current date, for instance, which was a minor fix, but that's one of the simpler ones I did. But yeah, lots of people use this. If I were to go to users, I don't know how many hundreds, it might be in the thousands now we have. So I know I'm making a difference, and that's a good feeling to have. Oops. Okay, and yeah, and this is just some of the code base. I'm sure it's proprietary, but you're not going to get much just from a single file. But this just is showing you what it's like to start a career in app development for a company where the app's already there. You're going to basically be given a couple hundred files, some of which can be thousands of lines long. This one's only 439. And yeah, you got to figure out how they all work together, which can be really challenging. And depending on the company, it can be a nightmare. But also depending on the company, it can be really well organized. One of the places I worked, it was really well organized. And in that case, it was fun. It was like basically solving a puzzle. They left you all the clues in good places. You learn how to search for the other clues to find out where things go. And then it's just a matter of plugging things in where they're supposed to be. And I personally found that rewarding. Okay, I've only got a couple slides left before I conclude 4 questions. Oops, wrong one. Okay. I would feel remiss if I didn't mention a teaching career, by the way. So that's mostly what I'm doing right now is the high school instructor. And the pros of doing this is that you are contributing to preparing the next generation. Because as I mentioned, computers are everywhere. Our society revolves around computers, and that's only going to become more and more true as time passes. So therefore, it's really important that more people learn how to program, especially since there is a constant shortage of programmers out there. That's why it's so easy to find a job in computer science development. Well, one reason, because everyone needs software developers. That said, there's also a big need for comp sci teachers. Almost as big of a need as there are for students to take comp sci, because there's a shortage of people who are interested in it. If you teach computer science, you get a lot of freedom in how you present your material and the extracurricular stuff that you do, which is kind of true for pretty much every teaching job. But depending on how you teach, you still have to teach the approved curriculum, so that does restrict what you can do a decent bit. And of course, at least in the US, the pay is usually lower compared to the other options like app development or web development. And you're going to most likely make less use of the programming skills that you have, unless you're putting in a lot of effort into making really cool examples, which is something that I like to do from time to time. Okay, I got 2 more careers that I've worked on over the years. First is web design. I've only done it for myself, honestly. I have not ever marketed myself as a web developer, but I have done it. And I know other people who have, so I feel like I am comfortable talking about this. So one of the pros is that depending on what kind of web design you're doing, it can be easier to get started in. So no disrespect to the front-end developers out there, but if you're getting only into front-end development, it is in some ways easier than if you're going into back-end. It's easier in the sense that it is a wide it is a wide knowledge base rather than a deep knowledge base. So some people find that easier. Not everyone does, but that's from my experience, which admittedly is not much, what it's like to be a front-end developer and not a full-stack developer. You would be more focused on having good design chops, which I put as cons, but honestly, that should be a pro or a con. Depends on if you're more a creative person or a technical person. So front end is really good if you're a creative person. I'm not, so therefore I'm probably not that good at it. And that's a sales skilling that's different from the technical know-how, which is what I was referring to for the easier part. A pro of it is you can make your own website for free, which is what I did. Here is my website over here. It automatically generates the pages for some of them. like this one right here, as long as I go to my JSON file here, which I don't know if it'll let me show. No, you have to download it. Okay, I'm not going to open that up, but basically if I just input a new book's information in here, it will automatically display on this page over here next time I load the web page. Well, I need to do one more thing. I put the data in there, and then I just basically copy paste this file and change which book to load, and then it automatically produces. Well, wait. This page automatically adds it. It will also add a completely new page specifically for the book. After I make that other web page, it's basically just copy paste. And it does automatically link to other books in the series. But if you're not working for yourself, then you have to do what the client wants, even if what they want is a bad idea, which is something that happens a lot. That said, it's an easy job and relatively easy to find a job, so long as you have a good portfolio / resume. And it's also one of the jobs where it's easiest to work freelance. So if you want to work from home, set your own hours, set your own clients, web design is a great way to go. And finally, research career. I have spent more time in my research career than any of these other ones. So, pros to a research career. Oh, by the way, this is one of my favorite graphs that I got from my largest research project. I can talk about it in a minute when we look at the dissertation that I wrote. Pros are that you get exposure to a lot of programming languages. You'll get a lot of exposure to lots of languages anyway. But when you're in research, you're much more likely to get into some of the esoteric languages like Erlang or Agda, stuff that people don't usually use in production, but that they want to research. You have a lot of freedom in what you do, so long as you know how to push for that freedom. And one of the coolest things is that you get to work on cutting edge machines. Just for this graph alone, you can see that I was working on over 8,000 domains, actually over 13,000 domains, which are basically cores. Because when I was working in research, I got access to a lot of supercomputers. I do not remember what the biggest one was, but I believe the largest run I had was 16,000 cores across, I think, 1,000 nodes. Where a node is basically a standalone computer that you've hooked up to a bunch of other computers to make what's called a cluster. That's what most supercomputers are these days, although they were moving into a different direction, I believe, and this was about 5 years ago, so things might be different now. But yeah, clusters are still a major kind of supercomputer. You also get to contribute to technological advancement, which is kind of satisfying. At the same time, I will warn you, it won't really feel like you're doing that much, because when you're in research, you're typically making baby steps. That's really what research is these days, is baby step, baby step, baby step, and everyone's baby steps together lead to big leaps. Now, one of the pros is that you get to do a lot of research, so you get to really understand what's out there in terms of the cutting edge computer science field. Cons of this are that there's obviously a huge time requirement that you need to invest towards your education. You are not going to be going into computer science research until you are either late in your undergraduate career or early in your graduate career. Well, basically as soon as you get into graduate career, most likely. The money is what decides what you get to research, though. You will push for what you want to research. Like once you get into a full-scale research career and you're your own professor, you will apply for grants to research what you want, but you still are constrained by what the government or whatever other clients want you to do. If you get any left over, then you can fund yourself. I mean, no, you don't do stuff that's left over. That's bad. I didn't say that. If you get enough money of your own from payment, then you can fund your own research there. That said, the field is extremely competitive. It is really cutthroat in the research industry. They're not supposed to, but they will try and sabotage you just because there's only a limited amount of research money to go around. So they're not going to actually mess with your research. If they do that, that's illegal. but they will, curry favors from the people who, there's a lot of just like relationships built into that. It's kind of who you know in addition to what you're doing. So it's really competitive, and you need every advantage you can get if you want to fund your own, if you want to pursue your own research. And again, con is, depending on who you are, lots of research required. If you don't like doing that, do not go into research, obviously. Really quickly, I just want to show what the research was that I did, my dissertation. I'm not going to go through the whole thing. It's 179 pages. Where is it? Here it is. But this was my biggest project. It's not the only paper I wrote, but this was my dissertation, and therefore it's the biggest. So this image right here, this is basically the most simplified version of a model of how the programs we were running worked. It was supposed to generalize how all computer programs work if they run on what's called our runtime system. Basically, it's an application that runs other programs in such a way as to make them be scalable across a large supercomputer. And I was trying to make a model to predict how they would behave so we could see before even testing it if it would do well or not. So this was a 2-core, 2-node model with only 2 memory banks per core. And it was just a quick little demonstration right here. But if I scroll down a few pages, oh yeah, and I also was timing different operations to get how each part of the model should be simulated. That goes through quite a few pages. And eventually we ran the actual application, and then we compared it to the simulations. So this graph right here, this shows how this application called Louisiana would perform using different runtime systems. So HPX1, HPX2, HPX3, and MPI is not a runtime system, but it is a special library. MPI is what we were trying to beat, basically, and we got close. And we were trying to figure out what was going wrong based on the model. Here's my favorite graph, again. So this is showing based on how, so one thing I did was I had to update the runtime system itself. I had to program it to take measurements and be able to tell when it was doing different things. I also had to update the applications we were running to test that. And that's what all these different colored regions are. They say what the application was doing at different times. That way we could see what was taking a long time, what wasn't, and maybe figure out why our version was not going as fast as MPI's. Here is a more detailed version of it. It's saying what cores are active. Well, it's not detailed. It's a similar graph. This says which cores on the supercomputer were active on a particular node at different times, and where there were these things called, I believe those are the all reduces, right? No, yeah, those are all reduces. Basically where your program had to stop and wait for every core to make sure that they were synchronized. And from this, I was able to come up with a few reasons why our application was not doing as well as MPI's, why our runtime system wasn't behaving properly. One of the biggest things had to do with the all reduce. The all reduce was kind of killing us just because we had a poor implementation of it. And just a couple more slides. So this was comparing what we saw with our actual timing versus what the simulation was. So blue is actual. My prediction based on simulations, that's orange. And so for Louisiana, you see my model worked really well. It was roughly giving us the same numbers. For other applications, it didn't do quite as well, like the HPCG app. It did well for a single core, but for multiple cores, it didn't. I had to come up with explanations for why that wasn't working. But yeah, this was my research that I spent at least 3 years on, basically, was all of this. And with that, I'm open to questions.
So you mentioned how the research field was very cutthroat. So how do you make like an actual living out of it? So you said you get grants and stuff from the government, but what percentage of that goes to you yourself that like to get like sort of I guess a living wage? I guess how does that work?
Okay, so I want to caveat by saying I was never involved in grant applications. So what I'm about to answer, I only know from just observation. So I might not be completely correct. But if I remember, you have to say what different portions of the funding are going towards. So you set aside a cut, you say this is how much you're paying your researchers, and you're going to be included as a researcher. And then you can divvy that up. I believe it's up to you how much each researcher gets. You say how much goes towards equipment, towards other funding, like you need to pay for usage of the supercomputers. So the grant money, you request a certain amount, you tell them how much you're going to be using each bit for, and whatever part you allocate as payment for yourself, you keep. That's your compensation for doing the research.
All right, Mr. Daniel, I've got another more general question for you.
Mhm.
So when it comes to programming languages, obviously there's a lot of programming languages, and you probably have a ton under your belt. But which ones do you know? And out of those, which ones would you say are your most favorite, or you frequent the most in day-to-day basis?
Okay, that's a very good question. For the ones that, okay, they're both good questions. But for the ones that I know, let me caveat that by saying, as I change fields, I stop using other languages and they get rusty. So when I say I know them, I should say that at some point I was good with them and I could probably pick them up again later if I were to do so. My first language was C++, and as such, it has a special place in my heart. It is not the easiest language to learn, but it is really powerful. C is a little bit easier, and in some ways it's more powerful, in some ways it's less. It's a good alternative. C sharp, I have not used that much, but it's basically like from the exposure I have had, I think it's like a baby between C++ and Java. Java, I've used a decent degree. It's very easy to apply to different hardware architectures because of how it uses It uses a virtual machine to run on. That said, the libraries are kind of awkward in there. It's not my favorite. I've also used R briefly. I did not enjoy it, but also never really got into it. I used Scheme. That one was fun, but I'm pretty sure that's niche. Python is really good for scripting. So if you want a quick language that you can just pick up, go with Python. It's great for scripting. JavaScript is the same way. It's good for scripting and it's applicable to a lot of web development, and it's pretty easy to pick up. Other ones I've learned, don't go with Agda. Erlang is cool, but again, that's something that's very niche. OpenML, technically Prolog, but I honestly never understood how it works. That was a single class, and I don't know how I got through it. What else? Were there any others? I mean, Bash scripting, I guess you could call that a language. I feel like there's one I'm forgetting, but I don't remember what it is. So as far as I'm concerned, yeah, that's about it. There is definitely one I'm forgetting, but I just can't remember what it's called.
Did you do SQL?
SQL is not really a programming language; it's a database language. Okay. But yes, I have worked with SQL. It's been a while. I also worked with something called Sparkle, which is a graph-based SQL language. Oh, Fortran. I use Fortran. That's not the one I was forgetting, but I have used Fortran too, which no one uses. And BASIC, which no one definitely uses anymore. That just shows how old I am that I mentioned that one.
Okay, I'll ask the next question, which is from the chat. Someone was curious about what the longest research that you've done is.
That would be that dissertation I mentioned. That one, I'm pretty sure I was working. Okay. If you were to ask my professor, I was working on it for 7 years, simply because I was working with HPX for that long. However, I would argue that it was only like 3 or 4 years that I was actually working towards that dissertation, just because a lot of stuff changed, and it wasn't officially that I did not officially start working on that modeling part until towards the end.
All right, there's another question in the chat. It is, which coding language do you think is the most marketable / most useful if you would want to work at a tech company?
That's a good question. I keep seeing it change. I haven't looked at the Java job listings in a while. I have noticed that it changes, and it also depends on what you want to get into. If you're going to go into research jobs, I mean, yeah, you need to first of all get into graduate school, most likely, but things like C or C++ or Fortran, and Fortran especially if you're not going to be a programmer, if you're first and foremost, but you want to be a physicist, because so much legacy code is built on Fortran that is a increasingly valuable skill to get the old code still running. JavaScript is perhaps the most marketable for web development just because it's used everywhere. C# is probably the most marketable if you want to go into general app development. And I don't know if Java is still a good one or not. I'm not seeing it as much, but like I said, it is something you can run pretty much anywhere so long as you have a virtual machine installed.
All right, so I had another question, more about your own future plans. Do you think you'll continue teaching computer science to students? Are there any like current projects that you're working on that you're going to be extending for the future?
Okay, so my current plans are to continue working at Operation Spark. I don't plan on stop teaching quite yet, mostly because I'm the only person who is teaching the Internet of Things course, which is that Raspberry Pi one, and so if I stop, that course stops. However, I have recently been having my position shifted, and I'm going to be more in the curriculum development side of things now and the actual app development side. So there's a lot of work we want done on this website, and I'm not the lead developer by far, but they want me to put more effort into furthering the development of this website, especially because we're starting to look into asynchronous courses, and they want me to take the lead on that. So I'm slowly moving away from teaching, but until they have someone to replace me for the things that I teach and the location that I teach over in Baton Rouge, because I'm the only guy over here, I will still be teaching. What happens after that, I don't know. I can see this, I'm still going forward with this at least a couple more years. So I'll worry about what happens when we get a little bit closer to that time.
I have my own question. I was wondering, how was your school life balance as a PhD student, and how's your work-life balance like now?
So my school life balance was actually really nice as a PhD student, but that's because I had a good professor. It really depends on who your professor is, and unfortunately, that's hard to tell. As someone who went through the whole thing and saw my peers going through the whole thing, I can tell you it's not always easy to tell who's a good professor and who's not, especially because you really don't see how they treat their students unless you talk to their students. I'm not going to mention any names, but I know someone who they had a average in terms of how hard they were professor, but because of a situation with where they were going to school, they switched schools and went with a different professor, and that was a huge mistake. Basically, that new professor would not let them pursue their own research to graduate, and instead kept putting them on the professor's projects. So if you do that, you're going to have a very bad graduate life. My professor wanted none of that. He wanted me to work on my dissertation, which was related to his work. It's true, but he did not want me getting on all these other side projects, which other professors who worked with him kept trying to get me to do. And in fact, he would tell me to stop anytime I actually got roped into it. So that made things really straightforward for me. It still took 7 years because sometimes it just takes a while. And I think I'm an average case on how long it took. Some people take only 5. Some people were lucky and it only takes 4. But I knew one girl who it took her 10 years to finish her PhD. So it really varies. You just need to be careful and don't be afraid to ask other students before you commit to a professor if you're going to go that route, because it would really, really save you a lot of headache. Although sometimes you might not have a choice just because you can only have so many, your professor can only have so many students.
On the topic of college, what, I guess, sort of just split it. What do you think is the most valuable degree today? Because, there are different routes for CS today. We had a speaker yesterday talk about how there was the college route and there was a non-traditional route where you could do coding boot camps and such. What do you think is probably the best path for someone who wants to pursue CS? Should they go to college, get an undergraduate degree, get a master's, or should they pursue a like coding boot camp route, I guess?
So this is going to be another answer where it depends. It depends on what kind of computer science work you want to do. If you want to go into something where you're developing new stuff, and if you want to go into research, you have to go to college. Like, you're not going to get a research job. I guess you could, but you're almost certainly not going to get one unless you go to college and you go into graduate school. They really like that PhD, or at minimum master's, but they really like that PhD before they let you work on your own research. If you want to just have a regular app development, then it depends on the company you're going for. Someone like Google, they're probably going to want a master's degree. I know that they make exceptions if you have like a really good resume, because everyone cares about a good resume. And if you have connections, all the better, because I would be lying if I said connections don't matter in today's world. If you want to just work as a programmer who supports apps that are already there or are developing new apps, then honestly, going through the bootcamp route might be the best way if you just want to make money and want to do it as a programmer. But be warned, the good bootcamp approaches are really, really intense. Our Operation Spark one, for instance, if you want the actual one that will put you in a job position, we have 2 versions. We have the high school one, which takes over a year, basically, to get through. And then we have our adult program, where basically you've already graduated high school, you decide you want to do programming. It only lasts, I think, 3 months. But basically, it's harder than anything that I have ever done. Like, I respect the people who work at Operation Spark who went through it. You're looking at 10 to 12-hour days, 6 days a week. It is really, really intense. But if you get through it, that's only 3 months, or between 3 to 6 months of time invested, and $11,500, I believe, is the current tuition for it that you spend, as opposed to going 4+ years at college with whatever their tuition is. You'll get in faster for a lower cost, but it's a lot more effort all at once, and not everyone can handle just how much stress it puts on them.
All right, so I had a question that is a bit out of scope of what we were talking about today.
Mm-hmm.
But as a software developer, have you ever touched on different realms that are considered like really demanding, like data science, machine learning, artificial intelligence? Have you ever dealt with any of those as a developer?
I had some classes in college where they had me work on it. Like, I did some machine learning. I had 2 courses that I remember. One was for data mining, where you basically get a bunch of data and have it decide what's what. So, your basic decision algorithm. I had another one where I had to teach a program to play a game. I think the game was Go, if I remember correctly. So that was another AI one, but it was not using stuff like neural networks, nothing cutting edge. And the data mining one, we used existing software for the most part. We just had to tell it how to behave, and we learned how to use it. What were the other suggestions for cutting edge stuff that you had, William, Andy?
So data science, machine learning, artificial intelligence. Yeah.
So for data mining, for data sciences, yes, as I mentioned, I worked with that Sparkle for a while. It unfortunately did not pan out. That was one research topic that I went into where I did not get a paper from it because it was demanding and I was working on the dissertation. Again, my professor didn't want me working on other topics. It worked out well enough, but yeah. So for that one, I was trying to develop algorithms that would speed up the search, I believe, for Sparkle, but it didn't prove fruition to be fruitful.
Someone in the chat asked, where did you get your PhD, and what are some good schools to get a computer science PhD?
Okay, so I technically graduated at Indiana University. I started my PhD career at LSU. And for good schools, I'm going to be honest, I have not been keeping up with which ones are still good these days, but you should be able to look them up, like their reputations online. Generally speaking, the more expensive the school, the better. That said, the school itself doesn't always matter. The school is important for the background education that you get and for having the alma mater attached to your name for reputation. But arguably more important is what research you end up doing and who your colleagues are on your big papers. So if you have a big name professor, it doesn't matter too much that you're at maybe a lower quality overall school, because the field recognizes that professor. And so it's gonna, oh, wait, sorry, you're not talking about graduate school, are you? You're talking about a regular college, undergraduate?
I think they were asking, graduate school.
Oh yeah, so for graduate school, yes, it doesn't matter as much because if your research is good, then, and especially if you have other names attached to it that people recognize in the field, that's what they care about. They care about what your papers that you publish actually contain in them and who is attached to them. The school is far less important in graduate school than it is for undergraduates. That said, you do want to go to a good graduate school that has facilities that you want and access to facilities that you want, because otherwise you can't do good research. So make sure they have at least a decent supercomputer, good support staff for like funding, although your professor will mostly handle that. And it's hard to find out unless you go and actually talk to people there, or call them up on the phone or something. But yeah.
And I guess I had one last question. This will be the last question for you, Dr. Cogler. Oh wow! Oh my God! Just forgot. But for, I guess, since you did mention that graduate school, the school did matter. When you're applying to, like, say, companies, what do you think matters more, a school's reputation or your resume, the things you do within your undergraduate career? What do you think would carry more weight, I guess?
These days, it's mattering more and more what you've done, even in undergraduate. So that's why it's good to get an internship. Try and make sure it's paid. But getting an internship actually does help, so long as the internship is actually doing computer science work and not like data management work. I mean, if you're doing data management work, then you'd want to apply for a data management job, not a computer science job. But yes, the school does matter, although I've noticed it tends to matter, well, I don't have too much exposure to this, so maybe I've noticed it doesn't matter either, but the bigger the company, the more they care about the school, but also the more they care about your resume. It's a dichotomy.
Other questions, but I think we'll have to end it here. It's almost approaching 7. And so, any last remarks, Dr. Cogler? Or
Well, sure. Yeah. Personally, I found computer science really enjoyable. I had one bit of history that I never mentioned. When I started in high school, I really enjoyed it up until I was given a project that did not work out so well. And so I quit it for a while. But when I got back to it, I finally started. That's the whole reason I went back to graduate school after I graduated college. It's just because I remembered I had always wanted to go into game development, and I did dabble in it a little bit in undergraduate. And that showed me that one bad project is not enough to, it's not something that should turn you off from something that you want to pursue. Things can be better. And it turned out to be better. It's been really rewarding because, as I mentioned, I can solve my own problems now. That little 4D thing is just one example. I've cheated in some puzzle games by making apps to solve the puzzles for me when I couldn't. Probably not the best way to do it, but hey, I have made tons of little programs that help me with my own data management. Things like making sure I'm always synchronized with my students, for instance, with the code they have is, so I can always access it. Just all these little programs that help me out. It's been super useful, even if I don't really do too much after. Well, I'm doing more of it now, but even though I had a period of time where I didn't do much, it was still useful. And so I think it's worth at least learning a little bit about how to program, even if you don't want to have an actual job in it, just because it's everywhere and it can help you out.
All right, I think that is a great ending. Thank you, Dr. Cogler, for taking time out of your day to do this and demonstrating and telling us all about computer science. Hopefully, all of our viewers took something out of it, especially those wanting to pursue a PhD. They probably learned a lot about that as well. And so that wraps it up for this year's virtual shouting program. Be sure to check out the previous shouting programs we have on our YouTube channel. And I would like to say thank you, everybody, and have a great evening. Bye, all.
Have a great evening, everyone, and happy Thanksgiving.